I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GEMS Engineering Management Technical Campus, Knowledge Park, 3rd, Greater Noida. The subject that I teach in this semester is digital communication. The topic that I discuss today is Graham-Schmidt Orthogonalization procedure. Graham-Schmidt Orthogonalization procedure. This is the topic that I discussed today in this video lecture. In mathematics, particularly linear algebra and numerical analysis, the Graham-Schmidt process is a method for orthonormalizing a set of vectors in an inner product space, most commonly the Euclidean space Rn. Actually, when the student goes follow the books, the language that are used in the books are difficult for the students to understand. So I just give a real concept of this particular procedure, what we call as a Graham-Schmidt orthogonalization procedure. Try to understand the concept involved in this particular topic. Do not bother about the language that are used by the books. Try to understand the concept. Actually, this is the procedure to find a vector set from the given vector set. First of all, try to understand that. Means you are given a vector set, right? Now, with the help of the vector set that are given to you, you have to find out the a set of second vector set that contains the vector that are orthogonals. So actually it is the process to find out the orthogonal vectors from the given vectors. Is that clear? I again repeat. Actually, Graham-Schmidt procedure, or you may say Graham-Schmidt orthogonalization procedure, it's a procedure to find out the set of vectors, and all the vectors are orthogonals vectors, and you have to find out this set, which we call as a orthogonal set or orthogonal vectors from the given vectors. So this is that procedure, right? So what you have to given? You given a linearly independent set of vectors, and what you have to do? You have to generate an orthogonal set, right? So Graham-Schmidt process takes a finite linearly independent set of vector. For example, in our case, we have a set S. This S contains these vectors V1, V2, V3, V4, V5 up to Vk. For k less than or equal to n any integer, right? So you have this particular set of linearly independent vectors. The condition is that this V1, V2, V3 up to Vk are linearly independent vectors, right? So with the help of this V1, V2, V3, V4, Vk, you have to generate orthogonal set S dash that contains orthogonal vectors. Which one? U1, U2, U3, U4 up to Uk. So this Graham-Schmidt orthogonalization procedure is a procedure to find out this orthogonal set S dash which contain orthogonal vectors u1, u2, u3, uk from the set that are given, which is given S that contains linearly independent vectors v1, v2, v3 up to vk. I think student now can understand the concept in this procedure, right? Before going to the next slides, try to understand some basics of vector analysis, right? Look at this. What is this and how we read this? V is a vector, of course. U is also a vector. And how you read this? Actually, this is the projection. This is the projection. Projection of what on projection of what? Projection of V on what? On U. So how you read that? Projection of V on U means projection of vector V on U. And how you draw the projection? You just draw a perpendicular line on the vector U1, U. So if you want to find out the projection of V on U, what you have to do? You have to draw the perpendicular line from V on U, right? So the point where the perpendicular meets at U is that point is called projection of V on U. For example, like that, this is a vector. This is a vector, say U1, right? This is a vector V2. This is V2. This is U1. What you have to do? You have to draw projection from V2 on U1. So what you have to do? You have to draw a perpendicular line from V2 on U1. So now this point is called projection of V2 on U1. Now you write that projection of V2 on U1, right? And you have to what you want actually? You want to find out U1, U2, U3, U4 up to UK with the help of V1, V2, V3, VK, right? So first condition is that V1 and U1 are equal vectors, means not only equal, also have the same direction. Look at this, V1 and U1 in the same direction. So first vector is find out very easily. Whatever the V1 is equal to U1. So with the help of V1, you will find out U1, which are both are equal, right? And this bracket, where this bracket is called inner product of the vector V and U. This is the inner product of V and U, U and U, and this is vector U, right? Now try to move further. In classroom, I always now there is some connectivity issue. Okay, now in classroom, I always in front of the students, I always used to find U1 and U2. Then when I come to U3, all the students in the class speak simultaneously. Okay, sir, this is the U3. Not only U3, U4, U5, U6, right? So there is a trick in that. First of all, what is your motto? Your motto is to find U1, U2, U3, U4, U5 up to UK with the help of V1, V2, V3, V4, VK, right? So first of all, whatever the V1 is, it is a U1. So first vector is very easy. U1 is nothing, it is V1. Now come to U2. U2. How you calculate U2? Actually, U2 is equal to, first of all, try to understand U2. 2 means it is equal to two terms. Count term 1, 2, right? So 2 means two terms, right? Whatever u2, we start with v2 minus projection of v2 on u1. Projection of v2 on u1. So this is v2 and this is v2. And if this is v2, this is u1, right? So come to u3. Come to the u3. Now come to u3. u3 means this should be equal to three terms. Look at the 1, 2, 3, right? And how you start with? You start with v3 minus projection of, and look at this v2. This is v2 and this is v2. So if this is v3, this is v3, this is v3. Only difference is this u1, u2. So how you start u3? u3 is equals to, again, if you see the trend, this should be v3 minus projection of, again, v3 on u1, and third term is again projection of v3, but this time on u2 instead of u1, isn't it? Look at u4. u4 means you should have four terms, 1, 2, 3, 4, right? And we again start with v4. So we again have a projection of v4 in each term, v4, 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 right? The only difference is we start with u1 and finished 4 minus 1, that is 3. So look at, if this is u4, this should be start with v4 minus projection of v4 on u1 minus projection of v4 on, after u1 then u2 comes, after u2 then u3 comes. So this v4 remains the same. And what is u5 actually? If you want to, what is u5? Look at, now think about u5 by yourself. How you start u5? u5 means you should have five terms in that. So five term, how these five terms start? It start with v5. So u5 is equals to v5 minus projection of v5 on u1 minus projection of v5 on u2 minus projection of v5 on u3 minus, this is the extra if you compare with u4, minus projection of v5 on u4, isn't it? So ultimately uk is to vk. If you generalize this particular trend, what you get? You get uk is equals to vk minus j is equals to 1 to k minus 1 projection of vk on uj, isn't it? So this is a generalized term. So that chart is very much easy. It's a trick involved in that, and it's very much easy, I think, because you know the trick. So in that way, students are easily find out this u1, u2, u, and these u1, u2, u3, u4, uk are the orthogonal vectors that you get with the help of the given v1, v2, v4 linearly independent vectors, right? And this is the chart. So Graham-Schmidt orthogonalization process, in this, the sequence u1, u2, u3, u4, uk is the required system of orthogonal vectors and normalized vector e1, e2, e3, ek from an orthogonal set. So if you conclude this lecture, what actually you do in this procedure? It is a procedure of the calculation of the sequence u1, u2, u3, u4, u5 up to uk, and this is known as Graham-Schmidt orthogonalization. So Graham-Schmidt orthogonalization procedure is a procedure to calculate sequence u1, u2, uk, u1, u2, u3 up to uk. These are the orthogonal vectors from the given linearly independent vectors v1, v2, v3 up to vk. Okay. So that's all, and I just say that I always go through the previous papers when I take a certain subject. I always in touch with the papers that already be come in the examinations previous. And what I found that this particular procedure is not to be asked in examination till now. But this particular procedure is very important in the sense that this is a straightforward topic as far as the syllabus is concerned. So I just said that please prepare this procedure. And one thing is very important. This particular topic is not found uh, in most of the books that you follow, because that particular things that I take as far as this procedure is concerned, I take from Wikipedia rather than books that you normally follow like Sanjay Sharma, like that. So I request all the students to go through this, whatever I discussed today, rather than to follow books. So, and books, the language of the books is also not an easy. So please go through this, go through the contents that I discussed today in this video lecture. Right. Thank you very much.